Did you observe the thing that I did few seconds ago? Now sometimes you may think that this one is amazing. Actually this one is not an amazing thing. Now here I am trying to give a scientific explanation about that how I took it to a vertical position by using the center of gravity of the coconut. Now for easy understanding, I am taking a block which has been kept on an inclined plane like this. Now here, think that this block is very near to topple off. That means the normal reaction will exert at this edge perpendicular to the plane, and also the friction will exert parallelly upward along the plane, and here the weight of the block exerts at here. I take it as mg. Now here the forces capital F and R are forming a resultant force. Now think that this condition, this box or the block is at final equilibrium condition. That means it is very near to topple off. And so that my conclusion is that the resultant force of R and F exerts directly upward along the line of weight. I am taking this resultant force as R dash. So that if I am increasing the elevation of this plane by a small amount, then what will happen? Now here you can see that I have elevated this plane by an angle beta which is larger than theta. Now here you can see that the weight mg exerts like this, and the frictional force and the reaction, you can see them. Now here, if I am taking the resultant force formed by F and R as R double dash, previously as mentioned earlier, then look at these forces are exerting along two lines. These two forces are enough to construct a moment. That means the system will form a torque. Look at, there are two forces, R double dash and mg exerts at the same object. Now clearly this one is enough to construct a clockwise moment, and this one will topple off. Here I am selecting three hollow spheres which are identical. Now think that the center of gravity for this hollow sphere will situated at here. This one is the center of gravity. That means the point capital G is exactly at the center of this sphere. Now think that I am filling this hollow sphere partly by water. Now what will happen to the center of gravity? Normally it was at the center of this sphere, but due to this water column, clearly the center of gravity point will shift by a small amount towards downward direction. That means the point capital G will displace vertical downward like this. Now here I am filling water continuously, and then what will happen to this G point? Again it will displace downward. That means you can see that when I am filling this sphere with water, then the center of gravity point will move downward. Now think about the condition that I have filled the hollow sphere completely by water, then again the center of gravity point will exert at the center again. That means when I am applying water gradually into this hollow sphere, then what will happen to the center of gravity? It starts from the center of the sphere and moves downward and again races upward. So that I am using this theory to explain the position of the gravity for the coconut. Now here I draw a small diagram of the coconut. Now this one is the coconut flake. Now I have taken it as a nearly spherical shape, and do you know that the thickness for the coconut flake at the bottom area is relatively larger than the upper area. That means actually the density for the substance of the coconut flake is relatively larger in this region. This one becomes more solid and the thickness is relatively higher than the top. And also this one is partly filled by coconut water. So that the center of gravity for this coconut is nearly at a point like this. This one is the center of gravity. Now think a situation that I am keeping this one on an inclined plane which has a small elevation. Now look at here. Now here this one is the coconut that we use. Now here this one is the contacting point of the coconut flake on this inclined plane, and now here I am applying the normal reaction R and the frictional force F at here. Now here the center of gravity for this coconut will at a point like this, and so that the weight mg exerts at here. Now think about the resultant of these two forces F and R. Now think about the resultant force exerts at here for F and R. It exerts like this. I am taking it as R dash, similarly mentioned earlier. Now think about what will happen. Now these two forces mg and R double dash will form a moment, and so that this coconut will make a vertical straight position and will topple off.